The Leopard main battle tank is a force to be reckoned with. Running on a 1,500 horsepower engine, the 55-ton behemoth can hit a top road speed in excess of 70 kilometers per hour. And it packs quite a punch. With a 120mm stabilized smoothbore gun for precision fire on the move. Even then, this muscle car of tanks will still need some help when it gets into a really sticky situation. For a heavyweight warhorse like the Leopard main battle tank, you will need some serious muscle to pull it out of deep trouble. And for that, we have the Leopard Armoured Recovery Vehicle. The Leopard Armoured Recovery Vehicle is purpose-built for the recovery of damaged, overturned or mired tracked vehicles. Because it's based on a Leopard 2 main battle tank chassis and outfitted with some very powerful recovery systems, it has the heft and power to support operations involving these monster tanks.
We will tag along with the combatant on the move. So whenever they encounter any problem, our ARV will always be there. We will rectify on the spot. Those required spare which we don't have. Then we will assess the situation, maybe tow the vehicle back to the workshop. And once repair is done, we'll push out the vehicle to carry on for their mission.
A large crane with a lifting capacity of 30 tons is installed at the right forward of the vehicle. Controlled by joystick, it's used for heavy load lifting work or helps with the replacement of the Leopard main battle tank engine. With this much lifting power, the crane requires some very careful and precise handling.
When we are doing craning operation, you're supposed to be very stable hands, hook the thing, move the thing very stable. Because it's a very heavy load, if we jerk a bit, the thing will just swing and hit somebody. It's a safety issue.
To get a sense of how critical precision control is for the crane, automotive technicians who go through the Armoured Recovery Vehicle course are set a challenge during the crane operating module. Drop a pen, tied to the end of the crane, into a small plastic drink bottle.
You have to be very steady because from up there you cannot see. You can only see a parallax error, you can see it, so it took a long time to put it in. But through practice, you do it over and over again, it should be easy for us.
Being a 30-ton crane, precision takes a very important role. When it comes to real operations, this will build up our precision level, our skill level, and our confidence level in using the crane.
Preparation work for towing operations is normally done manually by hitching the tow bar to a casualty vehicle so that it can be pulled to a suitable location for repairs if needed. But now, with the Leopard Armoured Recovery Vehicle's combat recovery system, the entire recovery process can be done from inside the vehicle with two externally mounted reverse cameras. In a hostile situation where there could be enemy fire, the three-man recovery team sits snug and safe inside the vehicle under armor protection. As the recovery vehicle approaches the casualty vehicle in reverse, an A-shaped tow bar at the back is lowered. The operator uses one reverse camera to align his vehicle. As he gets closer, he toggles to another reverse camera mounted on the tow bar for the final hookup.
It's actually not a very easy feat because the reverse camera only shows you very confined space. Everything is very small, and to hook up everything, it takes a lot of practice, knowledge, skills and experience to use the CID device.
Some recovery operations are more than just a simple hook and pull. For vehicles that are really stuck, like this one here, the recovery team will have to use a series of shackles, tow cables, as well as the recovery vehicle's main mechanical winch to pull it out. The single cable pulling capacity of the recovery vehicle is 35 tons and can be doubled to 70 or tripled to 105 tons. In this case, the casualty vehicle will be winched out using a single cable pull, which means the force of resistance was calculated to be no more than 35 tons. With the help of a pulley block, the pulling capacity for this winching operation here is doubled to help pull out the casualty vehicle, calculated to have a resistance of up to 70 tons. Different factors need to be considered when calculating the amount of resistance from the casualty vehicle, so that the recovery team knows which winching method to use.
We have to assess how deep the vehicle is in. If it goes deeper, the more resistance you'll face. And secondly, is also the type of ground. If it's in a dry sand, you'll render less resistance. But if it's a swampy, cohesive mud, you'll have more resistance. The steeper the slope that you have to winch out of the situation itself, the more resistance you'll render. And also, if the tracks are able to rotate, you'll have lesser resistance to winch the vehicle out. With these four factors, we will calculate a total resistance, and this total resistance will give us a rough gauge of how much force we need in order to pull the vehicle out.
If you calculate it wrongly and the pull is actually more, the load is more, and the thing, your own ARV might go into the mud. So it's very important to calculate it slowly and carefully, recheck it, make sure everything is perfect before you do it.
Rescuing a tank is not an easy job. And you definitely won't come out of it smelling like a rose. For all the hardware, math and science that goes into every recovery operation, hard work and commitment are still important parts of the equation. The recovery team is expected to put knowledge and muscle to good use, in spite of the very unpleasant situations they sometimes find themselves in.
The mud isn't much of a problem. The mud on you, I mean, go back when you wash, okay, can already, yeah. It's not like, oh, it's mud, oh, I cannot touch it, I cannot, I mean, it's a job, you have to do it, you have to complete the job. Whatever you're going to do, you do it right, do it professionally.
It's part and parcel of what we have to face every day. So it's just all about the mindset and how we go about overcoming them.
I will definitely feel confident with this vehicle because basically I can offer to them all the help to make sure the operation and the mission to be a successful one.
We pull it out, we recover a tank, then if you recover a tank, you can bring it back to a workshop, you can fix it, you can pull it back out so that they can continue to fight. So that's very important in terms of numbers.
No matter in peacetime or in ops, every recovery situation is real for us. There's always a time limit for us to pull the vehicle out so that the combatants can have confidence in moving off their vehicle for its training or for its operations.